Okay, let's be real for a second. Technical interviews, they can be super stressful. You feel like you're on a stage and one little slip up could cost you the job. But what if you could kind of peek behind the curtain? Well, that's exactly what we're going to do. We are going to deconstruct a typical Python interview to figure out what the interviewer is actually looking for.
So, we've broken this whole thing down into a few key parts. We'll kick things off with the interview gauntlet itself. Then we'll get into logic, when you can't use the easy shortcuts. After that, it's all about solving puzzles with the right data, what it means to be fluent in Python, and we'll wrap up with a puzzle that's all about thinking outside the code.
Right, so first things first. The whole point of a technical interview isn't just about getting the right answer. It's about how you get there. The interviewer wants to see your brain at work. Can you take a big problem, break it into smaller pieces, explain your plan, and then, actually build it? Just spitting out a solution you memorized from the internet? That's not gonna fly. Okay, so this brings us to the first big category of questions. Logic, but without the usual shortcuts. They're basically designed to take away all the easy built-in functions you'd normally use. And look, the goal isn't to trick you. It's to see if you can solve a problem from the ground up, using just your fundamental logic.
All right, check this one out. It's a classic. Find the second largest number in a list of integers. Simple, right? But here's the catch. You can't use the built-in sort function. No shortcuts. So how would you do it? Take a second and think about it.
And here is a textbook perfect way to handle this. Look at what the candidate does. Before they even touch the keyboard, they talk through their plan. This is huge for an interviewer. The plan is so simple and smart. Just keep track of two variables, the largest and second largest, and only go through the list one time. That's it. And this code just brings that logic to life, doesn't it? They start off by setting both largest and second largest to negative infinity, a clever move to make sure any number in the list will be bigger. Then, as they loop through, check it out. If a new number is bigger than the largest, the old largest gets bumped down to second largest. It's so clean, so efficient. Solves the whole thing in just one single pass.
All right, let's level up. The next kind of question isn't just about pure logic anymore. Now, it's about knowing your tools. Can you pick the right data structure to solve a problem efficiently? It's about working smarter, not just harder.
So here's the next puzzle. Write a function to see if two strings are anagrams. And you guessed it, the easy way out, sorting them both, is off the table. This really forces you to think about what an anagram is. It's not about the order, it's about having the exact same count of each character.
And the really slick solution here uses something called a frequency dictionary. You might also know it as a hash map. The idea is simple. Instead of worrying about the order of the letters, we're just going to count them. It's a super powerful tool you can use for all sorts of problems like this.
Okay, let's walk through this code. First up, a sanity check. If the strings aren't even the same length, there's no way they're anagrams, so we're done. Next, you build that frequency map for the first string, counting up all the characters. Then, and this is the clever part, you loop through the second string and start subtracting from those counts. If you ever hit a character that wasn't in the first string, or a count drops below 0, game over. It's not an anagram. So simple, but so effective.
So now we're getting into what I like to call language fluency. This is where the interviewer wants to see if you're just, a tourist in Python land, using it like any other language, or if you're a true native speaker. Do you get its quirks, its idioms? Do you speak Pythonic?
And this question is a perfect example. How would you flatten this list of lists into one single list? Now, of course, you could write a normal for loop. It would work. But an interviewer who asks this is looking for something a little more elegant, a little more fluent. And boom, there it is, the nested list comprehension. It's just one line of code, but it says so much. It's clean, it's efficient, and to anyone who really knows Python, it's perfectly readable. This right here, this is what speaking Python fluently looks like in code. But hey, fluency isn't just about writing cool one-liners. It's also about understanding what's going on under the hood. It's about being able to look at a piece of code and spot when something's not quite right. A different kind of fluency, but just as important. All right, take a look at this little code snippet. It's a simple loop that prints the numbers from 0 to 4. But there's a line in there that's doing absolutely nothing. It's totally useless. See if you can spot it.
Did you catch it? It's that I plus 1. That line does absolutely nothing. Why? Because the for loop is in charge here. At the beginning of every single pass, the loop itself grabs the next number from range and assigns it to itli. So even though you're adding 1, the loop just overwrites it a split second later. Catching this shows you really understand how Python's loops work. And for our final category, we're leaving code behind completely. Sometimes an interviewer just wants to strip everything away and ask a simple question. Can you think logically? This is a test of pure deduction, no programming required.
So here it is. You've got 3 boxes. One is labeled apples, 1 oranges, and 1 mixed. Now here's the kicker. You know for a fact that every single label is wrong. Your mission, should you choose to accept it, is to fix all the labels by picking just 1 fruit from 1 box. That's it. 1 pick. Okay, let's just make sure we've got the setup straight. The most important rule, the one rule to rule them all, is that every label is incorrect. So the apples box is an apples, the oranges box is an oranges, and this is the real key, the box labeled mixed cannot be mixed. It has to be either all apples or all oranges.
And that right there, that's the secret to the whole puzzle. The one and only correct first move is to pick a fruit from the box labeled mixed. Why that one? Because it's the only box that gives you a guaranteed answer. You get certainty.
Let's really break down that logic. Your first assumption might be that the mixed box is, well, mixed. But the reality is its label is wrong, so it can't be mixed. That means it has to be a box of only apples or only oranges. And that means whatever fruit you pull out tells you exactly what's in that whole box. It's the only box where one sample gives you 100% information.
And once you have that first piece of information, the rest is like a domino effect. Let's say you pick from the mixed box and pull out an apple. Okay, step 1. You now know that box is actually the apples box. Step 2, look at the box labeled oranges. We know its label's wrong, and we know it can't be the apples box because we just found it. So it must be the mixed box. And finally, by elimination, the last box, the one labeled apples, has to be the oranges box. Boom, all 3 labels fixed from one single pick.
So when you put it all together, you see that a good technical interview isn't just a bunch of random trivia questions. It's actually a really well-designed test. They're checking your core logic, seeing if you know how to use the right data structures, testing your fluency in the language, and finally just making sure you can reason your way through a tricky problem. It's the whole package.
Which really brings us to the big takeaway question, right? Is the goal of an interview to find someone who already knows all the answers, or is it to find someone who knows how to find the answers? It's really not about memorizing solutions. It's about showing that you have the mental toolkit to figure out a solution to any problem, especially one you've never seen before. And that, at the end of the day, is what they're really looking for.